Welcome to Chemistry Wide. Today we will see absolute configuration. What is the absolute configuration? The spatial position of atoms or groups around a chiral carbon. Chiral carbon means we already seen it does not overlap with the other carbon. The chiral carbon, it is also called asymmetric or non-superimposable. The chiral carbon is determined by set of rules devised by Chan in gold pre-log designated as RRS configuration. The 4 substituent around a chiral carbon is labeled as 1, 2, 3 and 4 based on CIP rules. A curved arrow is drawn from the highest priority 1 substituent to the lowest priority 4 substituent. If the arrow point in a counterclockwise means anti-clockwise, the configuration at stereo center is considered sinister in Latin word. Sinister means left. If the arrow points clockwise, right side, then the stereo center is labeled or called R rectus, Latin right. The R is added as a prefix in parenthesis to the name of the enantiomer. For example, see here center of the carbon atom. So there is around 4 substituent or 4 groups. Here 3 is the viewpoint. 4th substituent is lower atomic number. It may be hydrogen atom. See here, this is the view. If we look at this side, the arrow going to 1, 2, 3. It is denoted R. R is rectus, right side. Here 1 is the highest priority and 4th is the lowest priority. For lowest priority means H atom, hydrogen atom. Highest priority, it may be oxygen, carbon, like this. Next example, here H atom atomic number 1 is the least priority. Oxygen atom atomic number 8 is the highest priority. Here 4th substituent away from observer and a view at 3rd substituent. See the below the diagram. The observer look at this in 3 at 3rd substituent. This arrow anti-clockwise 1, 2, 3. The opposite anti-clockwise is ROS. The observer look at this at substituent 2, the arrow is going to clockwise. See below. Next, Chan in gold pre-log rules. See the rules. First, a substituent with a higher atomic number takes place precedence over a substituent with a lower atomic number. See, here hydrogen is a least atomic number, then bromine, then chlorine, then iodine. So it means iodine is highest atomic number, bromine is lesser than iodine, chlorine is lesser than bromine, hydrogen is lesser than chlorine. Suppose isotopes of the hydrogen and deuterium atomic number is 1. How to priority for this? Here we should take mass number. Deuterium more mass than hydrogen. See the diagram. This is the hydrogen. This is the deuterium. Isotopes of hydrogen. This is going to third priority. First one is alcohol, second one is methyl group, third one is deuterium, fourth one is last is H atom. So when dealing with the isotopes, the atom with the higher atomic mass receives higher priority. Next, when the two atoms attached to the asymmetric carbon means chiral carbon. So please remember this. The asymmetric carbon as the atomic number, then the second atom is considered. See below the diagram. Here alcohol is highest priority, then CH2 OH methanol, then methyl group, then hydrogen group. When atom is doubly or triply bonded, the atoms should be duplicated or triplicated. For example, C double bond O should be assumed as, this is C double O, should be assumed as the carbon is going to center. Oxygen is one oxygen left side, another one is right side, and triple bond C triple bond N as like this. Carbon is going to center, nitrogen could around them. Example A. See, this is the central carbon atom. This is, we know that alcohol is priority first, second priority is triple bond, third double bond is going to third priority, fourth is hydrogen. Say carbon connected to two carbon, it is duplicated. Carbon connected to triple carbon, it is triplicated. Another example B. See, alcohol is first, second one is CHO aldehyde, third one is methanol, fourth is hydrogen. Here aldehyde group is carbonyl group, C double bond O, so it is going to second place. Here alcoholic group is carbon connected to by single bond, so it is going to third priority. Please understand this. Then if we try to duplicate it above the both molecule, aldehyde going to first place and alcohol going to next. Next, a missing substituent on a tetravalent carbon is replaced by an imaginary atom of atomic number 0. Here no for substituent, so we should consider imaginary atom X. X is going to least priority. Here there is ethyl group, this is methyl group, there is phenyl group, this is imaginary, sorry, here carbon is only 3 bonds, so we should take X imaginary atom, that is going to be see below like this. So X is 4th priority. So here imaginary atom, if we take this atom, this atomic number going to be 0, so this is going to be away from observer. Next, see, this is the 4th X atom away from the observer, imaginary atom, and atomic number 0, sorry, here is not 1, this is 0, please, this is not, so I written mistakenly, please, this is not 1, this is 0, okay, sorry. Next, advantages, it can be applied to cyclic compound. Cyclic compound means benzene or cyclohexane. It can be applied to compound with the multi-asymmetric carbon atom. Multi-asymmetric carbon atom is chiral carbon atom. It can be applied to compound which are disasymmetric in nature. For example, first one is allene, second is pyrene, third one is biphenyl. It is like this. Use of R and S notation has no correlation with D and L nature. Please don't confuse with dextro and Levio. Here, this is first priority atom, this is second, this is third. If we look at the third, fourth is X, this is X atom, imaginary atom, so away from the observer, so rotation is clockwise, or here V is at second, the second is second priority, first, this is first priority, this is third priority. The observer view at a second, it is going to away from the observer, it is going to fourth substituent. In case fourth substituent coming to observer, so one group going to 3 via 2, so one going to 3 via 2, clockwise is or anti-clockwise or counterclockwise is yes. If observer view at second, this is second priority groups or substituent view, it is going to fourth, so note at clockwise R is going to S, at anti-clockwise S is going to R. For example, glyceraldehyde, see the structure, glyceraldehyde, the structural formula, this is asymmetric carbon, this is asymmetric carbon, this is not asymmetric, center of the carbon only asymmetric carbon or chiral carbon. So this is going to, this CH, we know aldehyde group is carbonyl group, so C double bond O here, first is alkyl group, second group aldehyde, third one is methanol, fourth one is hydrogen. Rule 1, see the glyceraldehyde, it is converted to like this, 1 alcohol is 1, here ketone is 2, here OH group is 3, here hydrogen 4. This is away from the observer. Rule 1, please don't forget this, please careful, listen careful. So one, this is clockwise going to 1 to 3, we are 2, this is our configuration. Rule 2, towards to observer or towards us, see the molecule, so it is also going to clockwise, 1 to 3, we are 2, clockwise. So this molecule, the observer at between the 2 and 4th, if you look at this compound, this is going to anti-clockwise or counter-clockwise. Note, we seen at rule 1 clockwise is R, anti-clockwise is S. At rule 2 clockwise is S, anti-clockwise is R. Note, if fourth group is towards the observer, clockwise R and anti-clockwise S. If fourth group is coming to observer, the rule is reversed, clockwise is S and anti-clockwise is R. So glyceraldehyde, rule 1, see the glycerol side. This is the observer view at fourth substituent. So 1 to going to 3, we are 2, this is our configuration clockwise. Rule 2, towards the observer at fourth, this is view, this is view. So this is going to anti-clockwise, so observer, this is going to anti-clockwise R. The clockwise is S lactic acid, the anti-clockwise is R lactic acid. This is. Please subscribe the channel. Thanking you all. Have a good day.